The first example I'm going to do for section 6.2 is problem number 6. They give you the graph of y equals x squared minus 2, which is the parabola, and the graph of y equals x, which is the line. And they want to know the region bounded between the two curves. So in order to know the area of the region bounded between the two curves, I need to figure out where they intersect. Okay, I have that they intersect at -1 and 2, but I want to show you how I got that. They intersect when these two equations are equal to each other. So I get x squared minus 2 equals x. Now I'm going to solve this equation to figure out what x is equal to. X squared minus x minus 2 is 0. Factor it. Two numbers that multiply to -2 that add to -1 would be x minus 2 and then x plus 1. So I know x has to equal -1 and x has to equal 2. So now what I want to do is I want to set up my integrals. So I know that the area between two curves is the integral of the top curve. My top curve is the purple curve, which is x, minus the integral of the bottom curve, which is the blue one, which is x squared minus 2. And I got to put my dx's. And we should remember from when we first started talking antiderivatives, is the antiderivative of a difference is the difference of the antiderivatives. Well, I can go the other way and combine these two into a single antiderivative, taking into account that negative sign. I need to remember to distribute that negative sign. I can write this as a single integral from -1 to 2 of x minus x squared. A minus times a negative would be a plus 2 dx. And now I'm going to use my general power rule to take the antiderivative. General power rule of this would be add 1 to the exponent divided by the new exponent. So I'd have x squared over 2 minus x cubed over 3 plus 2x. And I want to evaluate this whole thing between -1 and 2. Which means put a 2 into the function, put a -1 into the function, and subtract the 2. Put a 2 into the function. 2 squared over 2 minus 2 cubed over 3 plus 2 times 2. Subtract when I put a -1 into the function. -1 squared over 2 minus -1 cubed over 3 plus 2 times -1. 2 squared is 4. 4 over 2 is 2. That's 8 over 3, so -8/3 plus 4. -1 squared is 1. 1 over 2 is 1/2 with a negative sign in front of it. Minus 1/2. -1 cubed is -1. -1 times a negative is a positive 1. Positive 1 times a negative is a -1. -1/3. 2 times -1 is -2. Times a negative is a positive 2. And I have 2 plus 4 is 6, plus 2 is 8. -8/3 minus 1/3 is -9/3, which is minus 3, minus 1/2. That gives me 5 minus 1/2, which is 10 halves minus 1/2, which is 9 halves, or 4.5. And that would be the area in between those two curves. Key thing I want you guys to remember is you have to find the points of intersection sometimes. And make sure that if you're putting a negative number into a power rule that you put parentheses here so you end up with the correct sign. Sign errors are the most common errors on these types of problems. Next thing I want to do is if they just give you functions and stuff like that, you need to be able to graph them. That's going to be your first step, is to make a rough sketch. I don't need the graph to be exact. You want to make a sketch so you can figure out which is the top curve or bottom curve, or the right curve and the left curve if you're going with respect to y. So I know e to the x. I'm going to do that one in blue. Looks something like this. E to the negative 2x, okay, is, so let's put a 0 in here, and it gives me e to the 0, so it's still going to be here, but it's going to go down a lot steeper because of that thing. So I have that curve. And then I have natural log of 4. Natural log of 4 is just a constant, and that's the equation of a vertical line. So I'm going to draw my vertical line. So now that I have those three graphs, I want to figure out where is the region in between those three graphs. Well, the region in between these three graphs is here. Okay? And if I look at it, I always have the same top curve. I always have the same bottom curve. So I can write my function as the integral from, well, x equals 0 to the natural log of 4. So from 0 to the natural log of 4 of the top curve, e to the x, e to the x dx, minus the integral of e to the negative 2x dx from 0 to the natural log of 4. And again, just like the last time, I can write this as a single antiderivative. I'm going to write it as the antiderivative, or the integral of 0 to the natural log of 4 of e to the x minus e to the negative 2x dx. And now I'm going to take the antiderivative. Antiderivative of e to the x is e to the x. The antiderivative of e to the negative 2x is e to the negative 2x divided by the integral of the inside function, since that's an integer. Well, the derivative of the inside function. Since that's linear. The derivative of negative 2x would be negative 2, so I'm going to divide by negative 2. A negative divided by a negative 2 would be a plus 1/2. And I want to evaluate this between 0 and the natural log of 4. Which means I'm going to put a natural log of 4 in, I'm going to put a 0 in, then I'm going to subtract the result. So I'm going to erase the work from the first problem and continue my work here. I do need to see the step where you're plugging everything in. So I'm going to have e to the natural log of 4 plus e to the negative 2 times the natural log of 4 over 2 minus e to the 0 plus e to the negative 2 times 0 over 2. And now I evaluate. E to the natural log of 4 is 4. E, okay, so let's look at my rules of natural logs. See, this is a log problem right here. I can't do anything with this until I get rid of that 2. Well, since that's a natural log problem, that 2 can come up here as an exponent. So I end up with natural log of negative 1 over 4 squared. So another way I could think about that is e to the natural log of 1 over 16. Okay, with the over 2 here. Well, e to the natural log of 1/16 is 1/16. 1/16 divided by 2 is 1/32. E to the 0 is 1. Negative 2 times 0 is 0. E to the 0 is 1. 1 over 2 is 1/2. 1/2 times a negative would be a negative 1/2. 4 minus 1 is 3. Minus 1/2 is 2 1/2, which is 5/2, plus 1/32. Common denominator is 32, so I multiply this by 16 over 16. And I get 81/32 would be the area of that curve, the region bounded by those curves. So the last example that I'm going to do where things are related on the x-axis is problem 14, which is y equals 24 times the square root of x, y equals 3x squared. So again, first thing I want to do is I want to roughly sketch those curves. Well, 24 times the square root of x is just the square root of x function that is scaled up. So 24 square root of x, it's going to shoot up faster. So if I put a 1 into the function, the square root of 1 is 1 times 24 would be 24. So I'm going to end up with a square root function that shoots up really, really fast. Okay. The next thing I have is 3x squared. Well, 3x squared and is the x squared function multiplied by 3. So if I put a 0 into my x squared function, I get 0. If I put a 1 into my x squared function, I get 1 squared times 3, which is 3. So I'm going to end up with this curve like this. So now I look at it and I figure out where do they intersect, and that's the region that I want to find the area of. And that would be here, this region right here. Well, I have my lower limit. It's going to be 0. What I need to find is my upper limit. And my upper limit are when those two equations are equal to each other. So the first thing I want to do is I want to solve this for x. Well, if I've got square roots and things, I'm going to want to get rid of that square root. So first thing I'm going to do is divide by 24. So I get the square root of x equals 1/8 x squared. Then I square both sides, and I get x equals 1/64 x to the 4th. Bring everything over to one side. So I get x to the 4th over 64 minus x equals 0. Factor out an x. And that leaves me with 1/64 x cubed minus 1 equals 0. And I can find out where they cross. This is factorable. Still, the cube root of the first, cube root of the last, first term squared, this times this, which would be 1/4 x, last term squared. Copy the sign, change it, always positive. We know the difference of cubes pattern, the trinomial portion. Oops, I forgot an x squared here. This pattern only going to give me imaginary answers, so I don't care about that one. I care about this one. So I'm going to set x equal to 0, which gives me this one, which we already knew. And then I get 1/4 x minus 1 equals 0. So 1/4 x equals 1, or x is equal to 4. They cross at 4. Now let's just do a quick check. 4 squared is 16. 16 times 3 is 48. Square root of 4 is 2. 2 times 24 is 48. So 448. So that's where they do cross. So now what I need to do is write my integrals. Well, it's the integral of the top function, which is purple. So it's the integral of 24 square root of x minus 3x squared. So what I'm doing now is I'm combining the first two steps I did in the first two problems. where I can write it as a single antiderivative of the two things. And I'm going to go from 0 to 4 dx. Okay? So antiderivative of that, so that's 24x to the negative 1/2 minus 3x squared dx that I'm taking the integral of from 0 to 4. Add 1 to the exponent. So add 1, I'm going to get x to the 1/2. Dividing by the exponent, dividing by the new exponent is the same thing as multiplying by its reciprocal. So I'm going to multiply by 2. Add 1 to the exponent. Which is 3, negative 3 divided by 3 is negative 1. Evaluated between 0 and 4. So now I'm going to put a 4 in, I'm going to put a 0 in, and then subtract. So I get 48 times the square root of 4 minus 4 cubed minus 48 times the square root of 0 minus 0 cubed. This whole term is 0. I still expect you to write out that term. Square root of 4 is 2. 2 times 48 is 96. 4 cubed is 64. And final answer would be 32 units squared. So I'm going to erase the board and come back with a couple more examples. The next example is problem number 18. It wants to know the region on the interval from 0 to 2 closed of the two functions 4x minus x squared and 4x minus 4. So again, the first thing I want to do is I want to sketch their graphs. Well, this one here I can factor out an x. Set each of those equal to 0. Those will tell me the x-intercepts of this upside-down parabola. So I have an x-intercept at 0. And I have an x-intercept at negative 4. Set that equal to 0 and get negative 4. Okay, and it's upside down. So negative 2 is going to be the x-coordinate of the vertex, just so I can get a rough graph. I just know it's going to do something like this. Okay, and I'm only concerned about the area for 0 to 2, so I really don't care how tall that goes. Next thing I want is this graph. It has a y-intercept of negative 4 and a slope of 4. So if this is minus 4 with a slope of 4, that means it's going to go up 4 and 1 to the right. And I want it from the interval from 0 to 2. Well, let's figure out where these two intersect. Set them equal to each other. And let's see really quick. Let's put a 4 in. 4 minus 16 is 0. Okay, 4 is not where they intersect. I'll actually put a 2 in. 8 minus 4 is 4. 8 minus 4 is 4. So they do intersect here at 2. Other option is to set these equal to each other. I'm going to move the x squared over. Subtract the 4x. Then I get x plus 2 times x minus 2 equals 0. X equals or minus 2. So yes, they do intersect at 2. So my integral is top curve, which is the parabola, minus the bottom curve, which is the linear equation, from 0 to 2. Again, I'm going to write it as a single integral, taking special care that I'm subtracting the bottom one. So it's going to be a minus 4x plus 4. So the integral from 0 to 2 of 4x minus x squared minus 4x plus 4 dx. That integral will simplify. These 4x minus 4x's go away. And I have the integral from 0 to 2 of 4 minus x squared dx. So this would be 4x minus x cubed over 3, evaluated between 0 and 2. Plug in the 2. 4 times 2 minus 2 cubed over 3. Plug in the 0. 4 times 0 minus 0 cubed over 3. That part goes to 0. 4 times 2 is 8. 8 over 3 is 8 thirds. 24 thirds minus 8 thirds is 16 thirds. And that would be, units squared would be the answer for that problem. And the last one I'm going to do is a split integral, but it's also one that I'm going to do in terms of y. So if I look at it facing this way, it's right curve over left curve, minus the left curve. So they gave you the function, they gave you a picture, so you don't actually have to solve this one to figure out where they intersect. I'll tell you the curves intersect at 3 points. They intersect at y is 0, y is 1, and y is 4. I'm going to do two separate integrals. I'm going to do purple over blue, and the purple one is the parabola-ish one. That would be this one. No, that's the blue one. That's the purple one. And y squared minus y is... So I'm going to go the integral from 0 to 1. So my first integral is the integral from 0 to 1 of the purple function, y cubed minus 4y squared plus 3y minus the blue function, minus y squared plus y dy plus the integral from 1 to 4 of the blue function, y squared minus y, minus the purple function, minus y cubed, plus 4y squared, minus 3y, dy. Now I'm going to do two sets of antiderivatives or definite integrals. Okay, first thing I'm going to do is negative y squared minus y squared is minus 5y squared. 3y plus 1y is 4y. Y squared plus 4y squared is 5y squared. Minus y minus 3y is minus 4y minus cubed. And now let's do the antiderivatives. This would be y cubed over, this would be y to the 4th over 4. Plus 5y minus 5y cubed over 3. Plus 4y squared over 2, which would be plus 2y squared, between 0 and 1. Again, no shortcutting. Write down each step. Plus 5y cubed over 3 minus 4y squared over 2, which would be minus 2y minus y to the 4th over 4, evaluated between 1 and 4. Okay, let's write out my work, substituting in my numbers. I'm going to put a 1. 1 to the 4th over 4 minus 5 times 1 cubed over 3 plus 2 times 1 squared minus, so everything I'm doing in blue will be this part. Put a 0 in. 0 to the 4th over 4 minus 5 times 0 cubed over 3 plus 2 times 0 squared plus everything in purple will be this group. 5 times 4 cubed over 3 minus 2 times 4 minus 4 to the 4th over 4 minus, putting a 1 in, 5 times 1 cubed over 3 minus 2 times 1 minus 1 to the 4th over 4. Simplifying, I get 1/4. I get 5/3. So that's negative 5/3 plus 2 minus 0. This is 64 times 5 over 3. So 64 times 5 would be 320 thirds. Minus 8. 4 to the 4th over 4 is 4 cubed, which would be 64. So it's a minus 64. This would be a minus 5/3. This would be a plus 2. And this would be a plus 1/4. Let's do some simplification really quick. 1/4 plus 1/4 is 1/2. So I did those two terms. 320 thirds minus 10 thirds. So 320 minus 10 is 310 thirds. 2 plus 2 is 4. Minus 64 is negative 60. Minus 8 is negative 68. And how can I get a negative area? We'll go with it. Common denominator is sixths. So I have to multiply this by 3, this by 2, this by 6. 6 plus 626 minus 640, 408.6, so I do not get a negative area. 623 minus 408 equals 15. 215 over 6. 3 goes into both of those. 3 goes in, no, it doesn't. 6, 7, 8. 215 sixths. And that would be the final answer. And yes, you may use a calculator to do this addition. I do expect the final answer to be as a fraction. So to do this multiplication and stuff that I did basically in my head and on the board, you may use the calculator to do that part. Final answer needs to be as a fraction, but I also need to see all of these intermediate steps. So you're not just sticking this into the calculator in one lump sum and getting a number. I do need to see the intermediate steps, how you're breaking them down to show all of your work. So this one was a little different. I did it with respect to y, and I also did this one split up under 2 different integrals. So those are your 5 examples for section 6.2.